record on this computer. Okay. So what I was saying, we're not going to take a look at the string two uppercase and two lowercase methods, because whoever submitted your solutions, the solutions were more or less correct. However, I would like to mention a couple of things in your solution. Okay, some patterns that I saw that most of you were doing in your homeworks, and I would like to address them. So the first pattern was imagine the code like this. This is a pseudocode. This is not, I'm not going to type a code that was part of your homework, just in a hypothetical situation. So let's define a variable, right? So it's called number or numeric variable, whatever it is. Let's assign 20. Now imagine we'd like to check whether this numeric variable, the value in this numeric variable plays in some kind of range, right? So it's greater than this and lower than this. So we have some kind of restrictions on the value of this variable. So let's imagine that these restrictions are the numeric variable should be strictly greater than 10, and it should be strictly less than 30. Okay, and then we're going to do some stuff here. You just delimit. Now this is an intentionally simplified case, right? So we have just two numbers. It is very simple and easy to kind of understand what's going on here. Even if someone who is not aware of your code, a code reviewer, an interviewer, whoever it is, they take a look at your code. It's pretty understandable and easy to grasp what's going on in your code. However, what if I do something like this? Is it now understandable what this code does? Yes, these are still numbers. However, is it understandable what this code does? I just changed the numbers, and now you completely have no idea what's going on here. So the way to mitigate such issues is to put these kind of constant values in some kind of constant, okay? Lower range and const upper range, for example. Now, in the scope of this example, now it doesn't mean, we shouldn't care what these numbers actually mean. However, my point here is that when we switched from simple decimal numbers from something else, or even if these are the numbers. Now, do you understand what this code does? Yes, you do. It checks for, we have some kind of conditional here. However, what is this number? What does it mean? Even if in the case of 10 and 20, you still might not, you can say we're just checking if the number is in 10 to 20, and we exclude both kind of, and the lowercase and the uppercase. However, what 10 and 20 mean, what these numbers mean by themselves, you do not know. So the way to mitigate that is to put such numbers in constants, right? And you declare them with the keyword const. And as you recall from my very first session, when I was talking about naming conventions, we should be using all lowercase variable names to convey the message that whatever you read here. Now, if someone, let's see, this code doesn't exist. Now, when someone reads this code, they immediately know, because there is a general naming convention. They immediately know that these are some kind of constants, okay? The naming convention conveys that message to whoever reads that. Now, this is much more readable than this, of course. And surely you should be selecting some variable names which even go further and explain the value. Okay, so since currently we don't care about the values, you should not only put your variable names in uppercase, you should also try to explain as clear as possible with the name of your variable that what the number, what the constant actually means. So this is to make not only the code reviewer's life easier, the interviewer's life easier, but also your life easier, because if in 2 months you come back to this code and read this, I guarantee you will not remember what was it doing there. So this is one pattern that emerged quite quickly from your homework. So my recommendation is to, whenever you are doing something like this, whatever it is, it does not have to be conditional, okay? So whenever you have some kind of numbers which kind of should not change during the execution of your code, consider them as constants and put them in respective variable names. Now, such numbers are usually called magic numbers. Magic numbers because when you look at the code kind of seems magic to you because you kind of understand JavaScript, but you do not understand how that works. And that's also usually what happens with the magic, right? So you see the magic trick. I mean, you can kind of see what's going on, but you cannot explain how it works. So it's the same thing is here. So this was a pattern that you should be aware of. I can't think of any other kind of patterns. Maybe, for example, you can also not do something like this. If you imagine you have a parsing statement, a function call, and you're trying to do kind of bunch of things here. Okay, so if number, then return number. Otherwise, check if float number, return, I don't know, int number, else return 0. Okay, so like again, some kind of hypothetical example here. We can break it down like this. Try not to do something like this. Okay, so just extract this part into some kind of variable, and then use that variable in your function call. Just try to write your code in a fashion that it's very understandable for you, for anyone who reviews your code. Whatever code you write, consider that code will be reviewed by someone else, even multiple people. Okay, so just try not to do something like this. Try to be empathetic. Think about the person who is not kind of familiar with your code, and they will be reviewing your code. So try to put yourself in their shoes and ask yourself a question. If it was me who was reviewing this code, imagine this is someone else's code, not mine. If I am reviewing this code, is this something that I would like to see? Usually, if the answer is no, then you should change the code. And this was one of the other examples that you had in your homework. Okay. So maybe we should implement a couple of, I don't know, array methods or something like that to satisfy your request. So maybe let's start with the easy one. Okay, so const for each. So what was the requirement? We would like to get an array, right? And would like to also have a callback function. Now, of course, I'm using array functions here. Now, the way our for each works, I think you recall that, right? So the way it works, we call dot for each on an array. We have this array of numbers, right? So now what we're going to do here, we are going just to a console log, whatever it is, console.log element, right? So when I say this code, we should see all our elements printed in the terminal, which is correct and which is expected. Okay, so let's see what other stuff we get in this callback. Okay, so variable 1, var 2. I'm just doing it with brute first. even if I would not look into the documentation, I'm just trying to see, are there any other kind of, is there anything else going on in this function? So let's go with console log for 1 and 2 and 3. 2 and 3. Argument of type where there's not a time of the problem for trying to be smart here. Yes, you know. Okay, so let me also maybe disable this. And okay, so what do we have here? So as we can see, I don't do anything with element. So var1 is 0 for the first iteration, then it's 1, then it's 2, then it's 3. It seems to me that var1 is actually the index. Now var2 kind of logs the original array, and to me it seems that var2 is the original array. Okay, and var3 looks undefined, which means I can just kind of simply, it looks undefined for all the elements, so I just imagine I can skip that. So so what I found out without looking at the documentation is that the callback function for each method accepts at least 3 arguments. So the first one is our element, the second one is our index, and that appears to be the index. If we take a look at the documentation, we'll see that's correct. And the third argument, which to us appears to be the original array, and if we took into the docs, that's exactly what it is. It's the original array. So okay, so maybe that means that in my original, well, not my original, but in my custom for each implementation, I should be passing all these 3 things to my callback function, right? So okay, so for my callback function, I would need to have my current element, the index of that element, and the original array. So the easiest way for me to do that without using the for each, the native for each, which was the requirement, we should implement a custom for each method, a function, without using the original for each method. So now we found out that the callback function for these native for each is 3 parameters. So the easiest way to do that is the classic for loop. So I'll go with let index equals 0, and index is smaller than array dot length. Length, thank you. And I'll be incrementing my index. So okay, now I have my original array. That's one of the arguments. I have my index. That's my second argument. Now I need to get the value. So and what I should do with these values, I should just pass them to the callback function. So I grab my callback function, and then I pass array I, which is my current element, then, well, it's not I, it's index. Array index, which is my element, and then I pass the index, which is, if you recall, is the second argument of our function, and then I also pass the original, or that's right. So now if I would do something like this, log 4, and then I would grab this callback function as it is. And then if I would just comment out this part, I would still have the exact same things logged out because everything is correct. So this was basically the requirement to kind of recreate a for each or to recreate these array methods and make them as close to the originals as possible. So this is the way I would do it. If I would not take a look at the docs, I would just see how many arguments are there. Do we have 3? Do we have 5? Do we have 4? So if var 4 or var 4, var 5, if this would return something, I would kind of understand that these are some values that can be used in the original method. So I would pass them to my callback. But since, as we've seen, that our fourth argument wasn't undefined, meaning we don't have to pass it anywhere. So that's why we go into 3. Now the map is actually very similar to this callback function, to the for each one. However, we also store the result of this code somewhere, and then we'll return an original array. So the way we can do that, we can say const or new array equals to an empty one. Then we would maybe need to say the result is this, and new array dot push the result, and then we just return new array. So this would be the implementation of the map. So the only difference is that now the only difference between for each and map is that we simply store the result of our callback call. Now with filters and there was sum and dot sum and dot every method. So this all of you got it right. So well, almost all of you got it right. So I don't think we should all kind of discuss that. And maybe we should also take a look at the reduce. Now, with the reduce, instead of the new array, what I'm going to have is an accumulator, which is an empty thing. So I'm doing the simplest case, okay? I'm not going to differentiate, did we pass the initial value or did we not pass the initial value? So initial value, I'm simply going to consider that in this example, that we always pass the initial value. So my accumulator is my initial value. Now, in this case, instead of storing everything in the result, we simply store everything in the accumulator itself. And then we'll return the accumulator. Okay, so this would be the kind of simplest way to, yeah, sure. I'm trying to reassign cost with job types. So this would be kind of the simplest way to implement the reduce, because now we pass our accumulator to our callback functions. As you recall, our reduce, the first value in our callback function in the reduce is the accumulator. Second one is the value. The third one is the index. The fourth one is the array. There is a fifth one, but we don't care about that. So in this case, now the difference between map and reduce is that instead of putting the value of the callback function, the return value into a new array, instead of doing the push, we are simply reassigning that value to the accumulator, and that's where the accumulation props out. This is the simplest implementation of the reduce. Now, of course, you should always differentiate the case where initial value is not passed, and in that case, the initial value for the accumulator is the very first element of the array, which is the one within 0. You would have to do all this stuff, right? And start the for loop with the correct index, etc. We're not doing that here. I'm just showing the basic implementation. So if you get the idea how this works, taking care of these kind of cases is very simple. Do we need to take a look at any other implementation? Okay. Reduce is the one that a lot of people got wrong in the first try. Some of you got it mostly right in the first attempt, had some small issues, but reduce was the one that majority of you got wrong. Okay, so could you please now, Oksana-Jan, share your screen and go through the quiz? Connect to the meeting. Open the quiz and just explain it the same way you explain it to me. I'm going to stop my screen sharing. Now, a lot of you sent me the correct answer, meaning the result, what the variable A holds, what the variable B holds. A lot of you did that. However, as I communicated multiple times in the main group, I'm not looking for the result itself, but I'm looking for you to explain to me precisely how there were only 3 lines in that quiz, like meaningful lines. So I was just looking for you to explain to me how these 3 lines exactly work, and why you would get that precise result. Okay.
Guys, we don't hear you. What about now? Yes.
But could you please and your
Still not hearing you.
do you hear us now?
No, yeah.
English.
I think whichever language you'll like.
Okay, I will try English, but if it's completely mad.
Yeah, well, I think you can.
So, yes, as I saw, it was completely a difficult task for me, because also spot is unknown. So first thing I saw it, I was completely frightened. And the first thing for me to solve it, to go with my fear, I looked at the tasks that are standalone. Then he's going to check our knowledge of his lecture, what he told, and I talked myself into starting from the safe ground to read the lecture and to watch those parts of videos that I did not write down in my bookable. So I watched it. It was a part of solution for me. And after that, I understand that it's not enough.
It was mentioned in my messages.
Yes, I remember it, but I decided to start from the safe ground, at least to start. So then I was again trying to persuade myself to do something, to give up, as I tried to find something that found me down, and I found the line. I know about it. It's arrow functions. So okay, first of all, I will read about the arrow functions. I thought I chose the MTN resource because it was recommended by teachers. It opens the arrow functions, read it from the start to the end, and so on. This thing that I found about this unknown what is that such brackets can be used when you want to start from a new line code. But it was not something that gave me understanding what is the entry inside this bracket. So actually then I just saw through the links in that article about the arrow function and accidentally ran into, it was actually a sheer luck for me. I ran into grouping operator. And when I opened the page of the grouping
I'll explain what is the grouping operator.
here, operator is at least two
Could you use your mouse for everyone else who is not here?
two ordinary, this is one. What
So the parentheses.
parentheses. And in that article, it was written exactly that the broken operator is usually used for make the precedence of the asset operators higher, and as the instance, it was an exact line where the comma operator was mentioned. So you and thought that at last that was it. And then already, when I opened an article about the comma operator, it was
Can you please show what the comma operator is there?
it is this line. Everything was clear after those article. After this article, comma operator works like this. It goes from left to right, evaluates each operand and evaluates both of these operands, but returns only the last one.
And which is the last one here?
The last one here is the right one. It's clear.
So what you're saying, what we would have here is we would add the numbers into the variable a, but then we would still do the multiplication and return that.
Yes, we will do first assigning operator because it's in the root operator. So
Actually, the result of this wouldn't change if we would remove the grouping operator.
yes, because
However,
after assigning operator works and multiplication operator works, the comma operator will go from left to right.
it will always go from left to right. So
He chooses the right one for returning.
So the grouping operator would be would make difference if we would have multiple operations in that parenthesis itself. However, in this case, since we have only one operation, the grouping operator is to more or less confuse you. Okay? If you were just to remove the parentheses around a plus equals x, the result is absolutely the same because we have a comma operator and all the operations would have to execute, and then x times x would return. So the grouping operator in this case doesn't do that much stuff. It's just simply there to kind of confuse you.
Yes, and the other tools that allow about it that we can use the operator in this current sessions where we want to put a multiple expressions into the place where only single expression is required.
Good job. Can you please give me an example with the variable definition of what that looks like? We're trying to define three variables, x, y, z. How would I do that with the comma operator?
In x, y, z.
Yeah, what I was more talking about is you can just say let z equals to 1, comma, x equals to 6, comma, y equals to 4. So no need to group there. So you can use the comma operator without the grouping operator. So that's what I was mentioning. Or let's put it this way to not confuse you. Just define three variables, x, y, z, do not initialize them and use the comma operator. if you would check the documentations for LED, var, const, that would be one of the first things that they talk about in documentation. So just define 3 variables, x, y, z, do not initialize them and use the comma to define this, to declare these variables.
Should we let for each?
Oh,
Remove.
only one let,
But
but you remove the equal. I said define 3 variables. I didn't say that x is equals to z. Correct. So this is another use of the comma operator. So let's continue with the quiz.
So, as we now know about homework, right? It becomes easier to understand what is the result. So first, A is calculated, and when goes through the original array, when creates a new array. So, and when going through the original array, iterated, we each time A is added X. So we received and start was the array when and the initial energy thing outside somewhere, or we can use it to be console locally to just see and hear yourself. This is a stamp was the array winning. Added to the considering X, it's just the ordinary map result of X, multiplying X.
Okay. So that was a complete explanation of these words. To just again sum it up. What we have here, these 3 lines, the only 3 lines that I was interested in were these. Okay. And the most interesting one was this. And the only thing that I was looking from you to explain what is this. This is the only thing I did not discuss with you. And as I said multiple times, there is a syntax we did not discuss. So, of course, we also did not discuss the parentheses with the arrow functions. You can do this only with the arrow functions. You can do that with the normal function declaration, because normal function declaration always requires you to have the parentheses around your code, even if you're returning one value. But with the array functions, the beauty of array functions is that you can just write x equals the greater sign of the arrow, and then if you write 1, that arrow function would return 1. So it just provides a nicer syntax to return these kind of values. Now, in this case, what the parentheses mean, it means we kind of want to return one simple thing. That's why we don't need the curly brackets, as we're not going to write many code. Now, but in this case, the problem is that we have the parentheses, which means we'd like to return one thing. We're not going to do complicated stuff, but we do complicated stuff because we do 2 actions. Now, the only thing, actually, if any one of you would just send me 2 words, comma operator, I would know you know how this works. But actually, Oksana sent me a whole lecture of how this thing works, and of course, the comma operator was also mentioned. So I know that she knows. She did the research how this works. But what I was looking from you were these 2 words: can comma operator. If you would just say that to me, I would know you know how this works. So again, what we do here, the parentheses here do not do pretty much anything. It's again to confuse you. If you remove these parentheses, it still works. Why? Because we have comma operator, and it works the way Oksana explained. It will do all the operations from left to right. Okay, so it would do a plus equals x first. So you would have your numbers accumulated or added to a first, and the answer for the console of a would be 15. And now what it does, when the last kind of operation in the series of comma operators occurs, that is exactly what is returned. And that's exactly why you would also have this result. Okay, so both of these are correct. The only answer I was looking for was comma operator. So good job. Okay, So what I'm going to do now is I'm going to talk about executing the code synchronously. And as you recall, as I mentioned in my last session, up until everything we did up until today, we did in a synchronous manner. So all the code that we had were synchronously. We did not have any asynchronously, any kind of callbacks or function calls we had. All of these were synchronous. So what I'm going to do now, I'm going to write a couple of functions, do some console logs in these functions, and then call them in one another, and maybe let's see how that works in JavaScript. Okay, so let's define our function do a, right? So do a, just a function which does something. Okay, so what we do here, we just console log a. It's very simple. So we'll be having multiple functions, and the naming, we're going to keep the naming convention. And what we are, however, going to do is the following. And function d. So what I'm going to do is I'm going to call my function b in this function a. Now, what I'm going to do then, I'm going to call my function c in function b. And lastly, what I'm going to do is I'm going to call my function d in function c. And then the way I execute this whole code is I call the function a, do a. Okay? So without running this code, let's just try to maybe guess how this works. And then let's try the code, and let's try to run the code and see the result. So let's start from the beginning, which is line 11. We have a function definition. Okay, so we define our function called do a, we do console log, and then we call something else. Seems to be a function. Now, when we go on line 17, we do see that the function that we're calling from the function do a is defined. So we should not have any errors. And what we do there, we console log b and invoke another function which is called do c, and it console logs c, and then it invokes another function called do d, and it lastly console logs d, and it doesn't do anything else. Okay, so on line 33, we invoke the function a. Okay, so how let's think about how this will execute. We execute function called d8. This code works. Now, to me, it appears that we will have a console logged and then invoke function b. Okay, so console log a, console log b, console log c, due to this nested function calls, and then console log d.
Let's
Was that a question? Do what again? Do you have a question? I don't understand, sorry.
I don't.
Now, the way all this works, if I would not write this line, nothing would have worked, because what we just do, we simply define functions. If you define a function, that doesn't mean you call that function. So you will not get any result. And if I would just say do d, what do you think I would get in console? Now I changed the function invocation from do a to do d. So I would see just function d. So whatever is defining function d, that's exactly what I would see. So now, can you see that these functions are nested in one another, right? So let's check, let's see the function do a. We have function b nested in function a. So when we call function a, we will have the function a to execute, and then we call function b, then we call function c, and then lastly we call function d. And since each of one of them console logs their kind of value A, B, C, D, that's exactly why we would get A, B, C, D, right? Because A, B, C, and D. Okay, so this is how the asynchronous code works. Okay, so let us add a callback function into our do wait. Okay, so let's add a callback function. Now what we do, we console log A, then run the function B, and then we do callback, and then we call our callback function. Here I would say do A in function console.log1. Okay, fair enough. Now we know the concept of passing one function to another. We know that functions are normal values you can pass around. So now let's see how this works, okay? Now, again, we're invoking our function doA, so whatever we have in doA will work. However, we're passing, instead of passing nothing, we now pass a function. And that function is called callback function. Now let's see how this works. Again, we invoke function, our function called doA, we pass the callback function. Now let's go to the definition of that function called doA. Now we have console log A, then we call doB. The function doB console logs B, then it invokes to C, console log C, invoke to D, console log B. And now when this kind of flow is finished, we come back as this function doB, what it does, it says invoke doB, then invoke to C, and then lastly invoke to D. Now, once this do D function invocation is done, we return to line 14, right? Because when we go deep into do B, we have a function called do C there, which is invoked. And inside do C, we have another function which is invoked to D. And then in the do D, we don't have any other functions to be invoked. We just console log stuff. Well, console log is also a function, but we do not have any other nested calls. So what we do our console log. And since this is our last invocation in do B, we return back to line 14. And then we would call our callback function. And what is our callback function? It is this function, right? So in the very end, then we would console log 1. And that is how it works. Now, if I would just move the places of doB and callback function, what do you think it will be logged? Yes. To the top? To the top, but where in the top?
The second after A.
So it will be A,
A1, B, C,
and the rest.
Yeah.
That's correct. Now, can you see how intuitive it is to work with synchronous code? It just works the way you think it works. It's super intuitive. That's why we really like to work with asynchronous code, because it just works the way you expect. There's not that many things going on with synchronous code, and that's why usually during the interviews nobody asks any kind of questions regarding how this synchronous code works, because it's just too simple. You read the code and it executes the way you read it. So nothing complicated there. Now the whole thing starts to get interesting when you go into the asynchronous realm. Okay. Now let's maybe talk how our JavaScript engine executes our code. So as you already know, we have some synchronous code and we have some asynchronous code. But what does that actually mean? With the synchronous code, as you have seen, this D or the console log D kind of awaits for C, B, A to be console log, and then it was being logged. So that's asynchronous work, right? It just awaits. C awaits before A and B are logged. It cannot be logged before A and B because we write it in a way that C is logged after A and B. So C has to wait for A and B to be logged.
C and D are waiting in a queue, and when do A gặp tại mà ấy tập thật không xin một tin queue mà nó mình chập stake it.
Oh, we'll get to that. They are not in the queue. C and D are not in some kind of queue because you log C when you get to C. If you do not get to C, there's nothing to put in the queue. Okay? You will have to execute console log to put something in any queue, right? But if you haven't logged A, you still didn't get to D, there is nothing to put in the queue while we are not at D. This is synchronous code. So, okay. So now we know that we have synchronous code, we have asynchronous code, and working with synchronous code is very simple, nothing complicated there, works the way we think it works. But in real life, it is quite hard to write any kind of meaningful applications, programs, which just do synchronous stuff. Why? Because the world simply doesn't wait for you to do your job, right? So even if you ask something, give me a JSON or give me a number, usually the world continues to spin while you're kind of asking this number. So everything usually works in an asynchronous manner. If you say, get me this tenant's name from somewhere, that is usually an asynchronous work, because when you say, get me my tenant's name, you usually do you continue doing some other work, and that system processes your request, right? So you are doing kind of different works. And once your tenant's name is ready, you have requested. Once that's ready, your request is fulfilled. Then somehow that system notifies you that it is ready. We can come back to my example with Starbucks, right? So when you're in the queue, that's a synchronous process. You cannot kind of push everyone out of your way and then go order something. That doesn't usually work that way. So you will have to wait in the queue and move forward one by one. So that's a synchronous process. But when you actually make your order, you order a coffee, espresso, whatever, now the asynchronous process starts, because you can work on your phone, on your laptop, and they will be preparing your order in the meanwhile. So you're kind of doing completely different things. You are not like standing and staring at the bartender, right? And kind of checking when your coffee is ready. You can do that, but usually you don't do that. So now that process is asynchronous because you are kind of not dependent on each other. You are doing your work, and once your order is ready, your name will be called. And that's why I actually brought that example with Starbucks, because they write down your name on the cup and they literally call your name, right? And that's where the concept of the callback functions comes in, right? So in real world, when you say, get me my tenant's name, what you do in your code is usually you say, get me my tenant's name, and when you do so, call this function. And give my tenant's name in this function. So that's basically the way it works in JavaScript. It's kind of the basic building blocks of asynchronous code execution. So now what we have in our engines is this thing called an event loop, right? So unless you don't have anything to do in your code, your event loop stops. And when you start running your JavaScript, you have this loop. It kind of goes through your code, picks up your function calls, picks up your variable declarations, and all these yellow JS boxes are these synchronous codes that being executed. Then you have some other things like set timeout, set interval. We'll talk about these today. Then you have some asynchronous input and output things. Asynchronous input output could be thought as reading a file, making an HTTP request. I don't know, asking some system to do something. That's an asynchronous input and output. And asynchronous means that when you make the request, you do not await for that request to be fulfilled. You do whatever you do. Whenever the result is ready, you will be notified about the result. That's how asynchronous process works. If it would have been synchronous, when you say, get me my tenant's name, you would just sit and wait for the tenant's name to come back to you, but you don't do that. Of course, it could be possible to do everything synchronous in JavaScript or in general in programming, but imagine how horrible user experience we would provide to our customers if they would click a button, the whole page freezes, right? The application awaits for the request to be fulfilled. Now everything is frozen. They cannot do anything else. Nothing is responsive. That's a horrible user experience. So that's why we have these asynchronous processes and things working in an asynchronous manner. So when you click the button, you have some kind of loading, right? You've noticed we have some kind of loadings, and I'm not talking about Service Titan only, right? Usually you do some kind of time-intensive work. You have some kind of loading indicator indicated that your work is being kind of completed or your request is being processed. And once the request is processed, once the work is done, somehow you are notified that the job is done. And then you can do something starting from there. So that would be the asynchronous input and output. Then you can also have some JavaScript to run that's synchronous. We'll talk about set immediate when we talk about set timeout and set interval. And that's pretty much it. So this event loop, it kind of works constantly until there is nothing to do. And whenever it just loops, whenever one of your requests fulfills, it recognizes that the request is fulfilled, and then it calls your callback. It lets you know, lets your code know that you have requested this file from the file system. The contents of the file is ready. You made an HTTP request to get your tenant's name. The tenant's name is ready. There you go. You can do some work with that. Now I'm going to show you how it would usually look like if it was 2014. And then we'll discuss in the upcoming lessons how we do asynchronous stuff in 2023.
Almost intuitively.
Pardon?
Intuitively is mean if you see.
Yes. Yes, before 2015, rather.
Was great. He's in fitness.
Yeah, and we're going to look at that confusing thing because you should be aware of that.
Arsen, can you please just to show where this one came from? I understand you removed the code, but I couldn't see the place where you console log one. Is it coming with the, here below?
It's in the chat.
Thank you.
So let's imagine we have this hypothetical function called read file. So we have a function read file from operating system. To just be clear that we're trying to read some file from our hard drive, whatever it is, SSD, from our local system. So the way I can kind of simulate how this would work in a slightly realistic way, I would usually have to provide some kind of path to file, right? So my function should expect to receive the path to file, and then somehow it should read what we do there. Now, what I'm going to do here is I'm going to say blah blah actually read the file. Call the callback with the result. Now result. Now, to not complicate things, because we're not kind of this is not a Node.js course, right? So to just not complicate things and to just kind of talk about my point here. Imagine what we do here is we somehow get the results or file contents. Okay, so somehow get this somehow. Okay. Now the whole meaning of the callback function or that asynchronous process was whenever we have the contents of our file ready, we should somehow notify to whoever called this function that the contents of the file is ready. So that's the whole notification mechanism. We somehow from inside of this function called read file from operating system should let the caller know that the contents of the file is ready. And the way we do that is we expect the second argument, which is a callback function. And then what we do is we pass our file contents to that callback function. Oh, let me put it here. Now the way this whole thing works is, for example, we're trying to read our text.csv file. There's a CSV file. We're trying to read the contents of that CSV file. Now, only passing the path name is not enough, because then this function doesn't pretty much return anything, right? So if we would say read const result equals to this result, and if we would do console.log result, this would be what? Undefined. Undefined, because we do not return anything from this function. Hence, implicitly an undefined is returned. Now, as you can see, I do not return my file contents from this function. Why? Because this is an asynchronous process. I never know when my file contents are ready. I do not sit and wait for the file contents to be ready for me, because the operating system, the JavaScript engine, they do some kind of asynchronous work. So me, in my code, I just cannot know that in line 11, my file contents are ready. No, the JavaScript engine will let me know when the contents are ready. Hence, I just cannot say return file contents here. Okay, so now we've established that this is undefined, and with the asynchronous code, we cannot do that. So then what do we do? So the way we solve this is we pass the callback function to our read file from operating system. And as we can see on line 15, our callback function then passes the contents of the file to that callback function. So what I do here, I would say content or text content, whatever it is, right? And then I can do console log the contents of my file is text content. Okay, so what we have here, this function, it is called a callback. Because why callback? Again, the concept of these callback functions. This function is called when the result is ready for us to consume. That's why our code will call back whatever the function we passed with the contents. So that's why this mechanism is called callbacks. And again, before 2015, this was the way of doing stuff. All your asynchronous functions would receive this second argument or the last argument or whatever argument it is. It was a function, and you would receive whatever you requested from your operating system, from your network, whatever it is in your callback function. Okay, so let's maybe create another function. Function send file to backend. text contents. Is there a question?
Can we use return file contents just?
No, as I explained, we cannot do that because this is an asynchronous process. When you say read this file, you in this code, or rather when you call this thing and you say read text.csv file, you never know when that file will be read. That's why you cannot say return.
Can we know that anything?
How do you mean? How do you know it's an asynchronous process?
Everything curves. But why?
Yes. So again, we come to the concept. If everything would be synchronous, the world will be kind of a worse place, because now imagine, let's take the example of the operating system. We have many programs running simultaneously. Imagine 50 of them are reading something from the hard drive. And also imagine that reading something from the hard drive, reading a Photoshop file, reading an image, opening a video, opening a text file, whatever it is. Now imagine if 50 such processes try to happen kind of simultaneously. What do you think will happen? Now every of these programs will say, I want to read this file. The other one will say, I want to read this file. And then you would have 48 other programs saying, we would like to read these files. But since this process of reading file is now synchronous, all of these 48 programs will have to wait for these two to read the file. So the first one said, I want to read this file. It reads the file. Now any other program can read the file. Now the second program will read any other file. Can you see how this works? So you would have a list of 50 programs which want to read files, and that would happen one by one. Now, can you imagine how this slows down the things? This doesn't actually how your operating system works, and this is not the way the internet works right now, because I just brought a small example. Now, in the scale of the whole operating system, there are many more file reads, like thousands. Now, imagine that you have a list of 1,000 calls. Each of them happens when the previous one completes. Can we see how this slows down everything? Cool. So now we come back to the idea that on the processor level, usually the current processes, which are made in current era, have multiple cores. And each core of the processor can execute code simultaneously. So now all these tasks, all these functions that say, I would like to read a file, they don't do that synchronously. They do it asynchronously, concurrently. And then what they also do, imagine we would like to read 1,000 files, and we have 16 cores, okay? So you divide this, like a very simplistic answer to just kind of explain the idea. This is not actually how things work. Now you divide this 1,000 file reads into 16, okay, for each core. And then you still have multiple file reads for each of your cores. Now what we get is we have, for example, 6 file reads for one single core, but we know that one single core can do one thing at a time. So now what we do something called time sharing, okay? So we say, start reading file number 1, we forget about that. Then immediately we say, start reading file 2, we forget about that. Now, on the level of the processor and the operating system, we have these kind of guarantees that such processes can be done in an asynchronous manner. Now, if we're talking about Node.js, you can read files in a synchronous manner, which means read this file, then you can do the return, because it's a synchronous action. You will not go to the next line until your file contents are read. Now, there are synchronous functions in Node.js. However, a lot of these functions are also asynchronous because, again, imagine you are reading a 4 GB file. Now your whole operating system should sit and wait while you're reading your file? No. Hence, these such processes, such I/O processes, which is input and output. So input could be, putting something in the file, doing some writes, and output could be reading something from a file, okay? Or doing some network call and reading the results, anything. So this is what I explain is part of the asynchronous input and output. And if everything would just be synchronous, nothing would work. So
reading fast. And so this is the synchronous process that happens in this function. Because it's not the order. Everything fast and synchronous.
okay, but it also can be synchronous. Now, as I was saying, I brought the example of Node.js because you can read files, write files, do whatever it is in Node.js, okay? So now, again, usually in Node.js, which is a JavaScript environment, you can run some JavaScript. You can do this asynchronous input and output. Of course, it is kind of asynchronous. However, usually they also provide the synchronous way of doing that. So reading a file, there's two kind of options to read the file. An asynchronous way to do that and a synchronous way of doing that. If you are usually writing some kind of simple script, like read this file and just console log the contents, you usually don't have to do the asynchronous way because it's more code to write and just not that convenient. So they also usually provide the synchronous functions of reading files, doing a network request, whatever it is. But in real programs, you usually don't do the synchronous stuff because, again, imagine you're clicking a button and then waiting 15 seconds for any response. Doesn't make sense. Everyone will just ditch your application, your solution, and go to a competitor. That's why we don't do synchronous stuff that often.
There can be no way. And what the way is the Asian callback function that mean that will return or give us a result from it.
Correct. So that's why. So using callback functions is one of the ways of doing this. Now, since this is not a Node.js course, I will not say what other options there is, but the basic asynchronous things in JavaScript, like the basic concepts of doing asynchronous stuff in JavaScript, start with callback functions. Okay, so since you just cannot guess or know when the contents of your file will be fully read, you just cannot return these file contents from anywhere because the process is an asynchronous process. When you call this function,
but business functions obtains the right action, it will wait till the end when the essential is finished.
When I get to explain the event loop more, I will answer that question. We're actually going to visualize how asynchronous code works, how synchronous code works, and you will see how all this stuff kind of connects together. Okay, so again, asynchronous stuff, we know. I hope we kind of at least get the idea why we need to have this callback function, because we never know when the contents of the file are read, and we need to have some kind of notification mechanism. So whenever the contents of the file are read, do something, which is call this callback function and provide the contents of that file to the callback function. And then I can provide this callback function to my asynchronous process and say, whenever the textual content of my file is ready, just do the console log. Okay. I know it doesn't look that intuitive, but the more you do JavaScript, the more you'll understand it. And then again, we'll also get to the part where we visualize asynchronous operations. So we'll have some visualizations today. So I hope that will also help you to kind of understand how this works. Now, what I was getting to, I was writing another function which takes the textual content, any text, and then it sends that text to some kind of backend. Doesn't matter. So we have the text content, and then we say send text to backend. Now we provide this function here. And whenever our kind of response is ready, we will call this callback function. Okay? So we have a generic function called function send text. Or you know what? Let me not kind of complicate things. I will just do it this way. Blah blah send text to the server, and call the callback function. Call this when everything is done successfully. Okay. So we have some more lines of code here. We don't care what they actually do. All we know that this function called send file to backend receives our text content, and it also receives a callback function. And when this textual content is sent to the backend, then we call this callback function. Why? Because again, sending the text to the server is an asynchronous process. We never know when the text is actually sent. So we need a notification mechanism. And that's why, again, we have a callback. When we call this callback, that's when we know that the text was successfully sent to the backend. Now, okay, let's come here. Now in this callback function, we have this variable called text content, and our task is now to send this text content to the backend. And the way we do, we simply call this function. We provide the text content as the first argument, because that's the definition of the function. And we also know that this function called send file to backend also expects a callback function. So let's provide that. Console.log file content is sent to the backend. Okay. Now, what if a hypothetical situation, after sending this file to the backend, we need to read another file. Let's do that. Read the file from operating system, text2.csv, content, okay? Text content. Now, what if we would also need to send the content of this text to the backend? Simple enough to do, nothing complicated. Content. And since our send file to backend expects another callback, we should kind of pass the callback and say console.log text content is sent successfully. Now, can you see where this is going? Now, what if I need to read another file and do something asynchronous from that? Can you see that we're nesting the code in one another? Why? Because the only way to guarantee, well, right now, okay, we haven't got to discuss promises. So currently, the only way to guarantee that our file is sent to the backend, that our file is read, to provide this callback function. That's the only way to guarantee. We cannot do returns. This is not synchronous code. This is asynchronous code. Whenever we read the file, we will be notified. Okay? It's not us who control when the file is read. We will be notified. We will be called back. So now the concept of callback functions is crucial, was crucial pre-2015 era to do the asynchronous stuff. There were some other implementations, but this was the main kind of way of doing asynchronous. Now, as you can see, if I would need to read yet another file, it just gets out of hand really quickly. Can you see how many indentations, kind of nesting we have? So the way of writing code is called the pyramid of doom, because if you would just turn the screen this way, you would see a triangle. So that's kind of the pyramid part, right? So this is your triangle. Hence, as you can see, and we're always nesting to the right side, and the pyramid or the triangle gets bigger and bigger and bigger. So this is what we call the pyramid of doom. And you would, again, have to nest all these calls in and callbacks in one another. And it just quickly gets out of hand. If you have like 4 or 5 asynchronous calls, it just quickly gets out of hand, as you can see here. This can be a very realistic example where you would need to read like 10 files and send the contents of these 10 files to the backend. But as how many files did we read here? Only 3. Now imagine I had some 7 file reads, then this code will just be unmanageable anymore. So this is the downside of callbacks. Yes, they provide you a mechanism to be notified when your asynchronous process is complete. However, the biggest downside of callbacks is that you have to nest them in one another to basically guarantee that your actions are complete. And this leads to that concept called the pyramid of doom. And when we get to the concept of promises, which will be in a few sessions, then we will see how we solve this problem with promises. Okay. Now if you think this was complicated, you should have seen some real world callback codes, and then it just this is okay, is what I'm trying to say. This is not complicated. But fortunately, we don't write asynchronous code this way anymore. Just to have it said, promises is the way to solve this problem. But what is a promise, how they work, we'll discuss in one of the future sessions. But now let's do some kind of visualization, okay? So to make it more interesting. Can I just hide it somewhere?
3 dots more, just then hide the second one.
This one?
No,
This one?
bottom.
This?
Yeah.
Okay, thanks. Okay.
Well,
Now, this is a website where we basically can kind of visually see how our code executes, okay? Now I'm going to explain you how this code works, what it does, and then we'll see the visualization itself. This is a synchronous code. Let's establish that. We don't have any kind of asynchronous stuff going on here. It's only 20 lines long. So let's start with line 1. We have console log 1. So we'll have this execute, we will have 1 log. Then on line 2, we have console log 2. We'll have this execute immediately. Then we have a function declaration, does nothing, just declares the function. Another function declaration on line 8, still just declares the function, doesn't do any of the logs because we did not yet invoke this function. However, on line 16, we do invoke this function called 3, and then what we'll see is console log 3, and then we have a function declaration of block. Okay, now what we do, this is a function declaration, we don't call anything, so nothing happens here. And then after line 16, we have console log last, and then on line 20, we console log, and we call this function called block. Now, do you think there is an error here?
Block cannot be called.
Pardon?
I think the block, function block, cannot be called because it is inside function suite. I think so.
Correct. That is correct, because we defined this function called block in another function, and anything you define or declare in your functions cannot escape to the outside world. So this is called kind of closures, lexical context, but we did not discuss this because this is not an advanced JavaScript course. However, our colleague is correct. We will get an error on line 20 because there is no function called block defined in the global scope. It is defined in the function 3, hence we will have an error. Now, on the right side, we have 3 blocks. We have something called call stack. Then we have something called web APIs, which we don't care about that right now. And then on the bottom, we have this thing called callback queue. So basically just ignore web APIs and callback queues, right? We currently were only interested in this tag called call stack, as this is a asynchronous code. Okay, so what is the call stack? So when you call a function in JavaScript, that call is being put in the call stack. So somehow your JavaScript engine has to keep track what will be called next, what was called previously, what is the thing that we're calling right now. So imagine the call stack is a notebook where the JavaScript engine is just writing down all the functions that you are calling, right? So when you say call console log 1, it will write down in that notebook, which we call the call stack, that someone tries to call console log 1, so do that. On the second line, it will write down in the notebook call stack, we are trying to call console log, so do that. Now I'm going to click this save and run, and I hope this code will be executed. Sometimes this website does some bit. So we will run this a couple of times. Okay, so no worries there. An error. Now this is the error that you said, which is correct. Now let's see the console logs here on the right side. So this side is called loop, and they just basically prepend this so that you know whenever you console log something from their editor, it's them who does the console log. So as you can see, we have our one console logged first, which is this line here, which is the first line. Then we have 2 console logged, which is the second line. Then we have 3 console logged. Why? Because we declare this function called 3. We invoke this function on line 16. Then we go into that function. We have console log 3, hence 3. We define this function called block, but we do not invoke that. So this text block will never be logged. So once we come to line 13, there is nothing basically to do. Then we are on line 17 and on line 18. That's why we have this text called last console log. And on line 20, we get a reference error, which is correct, which is what we should get. Now, again, I'm going to click this save and run button. Try to look at this callback thing and see how it works, because it's going to visualize. When it's about to execute the line first, it will highlight the first line and then also do something with the call stack. So let's see how it works. Now the second line is in call stack. Now 3 is in call stack. Can you see how the call stack is being built? So the way it worked, the way the call stack looked like when it executes this, it comes to line 16. It puts the function 3 in call stack because it's about to call that function. So this is what our call stack looks like. When we execute line 16, this is our call stack. It sees that we're about to call this function. It puts it into the call stack. Now it goes inside the function 3, and then it sees that we have a console log there. So the call stack continues to grow. We have this console log 3 in here. right? So let me do this way. Okay. Now it kind of builds the call stack. If we would have multiple function calls in here, right? So let me also put this no invocation call here, okay? So now the way this is going to work, now we're on line 18, it will see we're trying to call the function 3. So this is our call stack. Now it goes inside the function 3. On line 9, it sees we're trying to do console log. Hence, it adds that thing on top of the call stack. Now on line 11, it sees we're trying to call this function called no invocation. So it will put it into the call stack. Okay, so now since we're calling a function, we have to go inside that function to see what we have there. So the definition of function no invocation is the following. We simply do another console log. So this will be also put on the call stack. Okay, and let me just remove this function block. Okay, we don't care about that. So now, once we get to line 14, this will be our final call stack for this function, and then we will start executing from top to bottom. Okay, so we're on line 4, 3, console log, no invocation, console log. Did you see what happened? So it built the call stack this way and kind of started executing all the code. So again, this is the synchronous way of doing stuff, and this is a visualization. I will send these resources to you so that you can play around with some synchronous or asynchronous code. So just know that in JavaScript, we'll have this notebook, which is called call stack. And whenever you call a function, the JavaScript engine writes down the name of that function in your call stack. And it keeps adding all these functions in the call stack. And that's how it decides which function will be called when. And that is exactly how it works in JavaScript. So this call stack, every time I run this code, the call stack will be built in this exact same order, right? So no order of the function calls will be changed. Hence, it is so easy to work with synchronous code because we pretty much only work with the call stack here. Okay.
Where just the order should be a no invocation, and then 3 will be logged, right? Because we call 3 function in which we have the console log 3 and then no invocation text. I mean, the order is 3 and then writing the invocation.
Yes, that's exactly what happens. Well, what I show you in these comments is the way call stack is being built. Of course, when we come to this console log, we do the console log, then we remove it from the call stack. But I didn't do that because I would have to do that simultaneously with the animation, which I cannot. I'm not that fast. So I just built the whole call stack. And we, of course, when we come to this line 19, we do the console log. We will remove it from the call stack because we just invoke that function.
Mm-hmm.
So you're correct. Okay. Let me introduce to you a function called setTimeout. So in JavaScript, whenever you would like to defer the execution of something, for example, do something in 5 seconds or do something in every 10 seconds. You can do this in JavaScript, and the first option, do this in 5 seconds, is called setTimeout. Now, the way it works, it receives a function and a value. So let's define that function, and well, why don't I write this in my editor? Now, yes. So the way setTimeout works is we provide a function as the first argument, and let's for example do a console log. Console log set timeout worked. And the second argument of setTimeout is a number in milliseconds. So 5 seconds in milliseconds would be 5,000, which means in about 5 seconds, execute this function. Do you think this will execute before or after the set timeout?
Or because it is asynchronous. Is that
Correct. However, we will get to the explanation of this. Now, okay, let's imagine this whole code was synchronous. How does it work? We are online. We have only a few minutes to go, so I'll explain this part and I will left anything else as your homework. So if this code was synchronous, what would it do? We call this function called set timeout. We don't know what it is. We know it works synchronously. Then we provide a function, and then we say, run this function, invoke this function in 5 seconds. So if set timeout was synchronous, we would have to wait for 5 seconds and then execute this, right? Everything is synchronous, no asynchronicity right now. So we would wait for 5 seconds before continuing to line 13, then have the console log, and then move to line 13. But it is not how actually things work. Because now set timeout is a so-called web API, and that's where we have this second block. And this function that we provided to set timeout is a callback, hence we have this something called callback queue. So your homework would be to play around with set timeout, play some console logs here and there in this thing, right? And try to understand how it works. And I'll give you a simple asynchronous code example with set timeout, and you should be explaining how that works to me. Okay, but of course, since now this is an asynchronous code, the way now it works, it actually schedules this function to run in about 5 seconds. It doesn't, we don't sit and wait for 5 seconds for this to be executed. We schedule this in some way to run for 5 seconds. But again, as I explained, in asynchronous work, we don't sit and wait for each other. That is exactly why the line 13 was, the console log on line 13 was kind of executed first, right? So the way the JavaScript engine works, it will go through this line. It will see it's a set timeout. Okay, it will see, cool. I will schedule this function. I will not run this function. I will not invoke it. I will schedule it to run in about 5 seconds. So this actually executes first. Everything works correct. But since we schedule this function to run in 5 seconds, we're not running that function right now. We will do the console log of this. Do you think it will execute before or after the timeout? And then in 5 seconds, if I save this, and then in about 5 seconds, we will have this function, which is scheduled to run in about 5 seconds. We'll have it execute. And set timeout is a web API, so all that execution happens here. When we hit this 5 second kind of timeout, our function will be placed, or this callback function will be placed in another queue called callback queue. And that's where our main stack will be filled, right? So then we will, now since this is a normal function, right? We'll put it from web APIs into the callback queue, and then we will place it into the call stack and then execute that function. So I know it was hard today because talking asynchronous stuff is never that easy. So so that's about today's session. Again, I will send you the links. You can write code here. When you click save and run, it will exactly show how everything works. So you can visualize your code. You can do some experiments and see how set timeout will work. If you nest your functions, how that work. So this would be a very good exercise for you to understand how kind of synchronous and asynchronous things works. Was there a question?
We didn't over installable any output.
I don't understand the question.
You say that set time out will be in it is a web API and install and says web.
Yes, when you run
It was a function. I will be
not another function. So again, set timeout is not part of the JavaScript language. Okay, so set timeout is what we call a web API. So we have the JavaScript standard. It's a formal document which says how the language works. However, set timeout is not part of the language itself. It's part of something else which we call web APIs. There are many other APIs. So we have set timeout to run something in this amount of time. We can do something like this, run this code every 5 seconds. Okay, that's also a web API. So what I meant when I say web API, and we have this distinct also separation, this playground, that set timeout is not part of the JavaScript standard itself. It is a so-called web API. What is a web API? You can just Google and you'll see. There are many other functions and APIs that we call web APIs. And when I was saying that after we will have this executing the web APIs, I meant the set timeout itself. Now the callback function, which is this first argument, will then be placed in the callback queue once web API finishes its execution. And since this callback function is a normal function, we would have to have that function somehow transferred from the callback queue to the call stack and then execute the function. You will actually see this when you, let's actually maybe. Garanczacznie.
Stay calm with you.
Well. Now, are you looking how it works? No, I have our code in this editor. And now what I'm doing, I'm clicking save and run. Now set timeout executed in the normal call stack. Now we have our web API. We have the set timeout executing. Okay, now this is our 5-second timeout. We had our call receipt. Now we put the callback. This was the anonymous function. So again, let's do this one more time. Set timeout, our console log of that long string. Now we wait 5 seconds, put it into the callback queue, put this anonymous function then in the call stack, and then execute the console log. So there is a definitive path your code goes through these call stacks, callback queues. This is very important to learn when you are dealing with asynchronous JavaScript. So again, I will sending you this playground, play around the code, write some console logs, do some asynchronous stuff with set timeout. I'll also send you some other web APIs like set immediate or set interval to run this code every 10 minutes, whatever. Just play around, try to understand how asynchronous and synchronous code works. What is a call stack? What is callback queue? What are web APIs? And then for your homework later today, I will have a snippet of some synchronous and asynchronous code kind of mixed together. And by tomorrow, I will need you to explain how that works. Okay? There will be nothing complicated. However, again,
It increases on the code we do it.
no, sorry. This is the this is the software development. This is not QA engineering. Okay? We don't always have the correct or complete requirements defined for us. So usually we'll have to kind of produce something ourselves. So welcome to the developers world.